Hey everyone, welcome back to my channel. So today we'll be going through another tutorial on the TI Inspire CX2 CAS calculator. And this is on the normal distribution. So let's get started. So here we have the X, it's a normal random variable with mean of 10 and standard deviation of zero point 0.5. So for part A is the probability of X is less than 11. So what I want to do is we want to put out our cast and go to menu, probability distribution, and go to normal CDF here, and then just go enter, and then your lower bound is going to be negative infinity, your upper bound is going to be 11, and your mean is going to be 10 as per the question, and then your standard deviation is going to be zero point 0.5. And then just go OK. And that's your answer there. So it's going to be 0.9772. So 0.9772. Okay, so that's 0.9772. And then for part B, let me just quickly share my screen again. So that's this one here. Okay, so for part B, so the probability of x is less than 11 given x is less than 13. So this is basically probability of x is less than 11 intersect with probability of x is less than 13 over probability of x is less than 13. So what that's saying is if this is your number line, this is negative infinity, and then if this is your 11, and then this is your 13. So x is less than 11 is going to be from here to here, and then x is less than 13 is going to be from here to here. So where the two intersect is just going to be at this point here. So the numerator can be written as probability of x is less than 11, which is the answer from part A. And then over probability of x is less than 13, and that will give you the right answer. All right, so we want to jump over to our CAS. Now, once we have this normal CDF up at the top, we can actually reuse that and just change the parameters to suit. So first of all, put up your fractions like that, and then just copy what you have there at the top and then paste it in the numerator because that's the answer from part A. And then paste again on the denominator and just change the second parameter to 13 because your new upper limit is 13 because the denominator is probably of x less than 13. And just go enter and that's your answer there. So it's going to be 0.9772. Now it looks very similar as part A, but you notice the later decimals are different. So they are slightly different in the answer, but overall it's still 0.9772. So let's bring that back up on my screenshot here. So that's going to be 0.9772. Okay, let's quickly clear this error here. All right, so let's go to the next question. So part C is um, find C such that probability of X is less than C is equals to 0.95. So what we want to do now is to use inverse norm to find what C is. So from the graph here, a normal distribution graph, so in this case, we're trying to find the C value here. So this is mu, which is the center point of normal distribution. So this point here for C, the area under the graph here is going to be 0.95. Now, the reason why I drew the mu here is because at this point, this is going to be 50 here. So that's why the C is on the right hand side here because it's more than zero point 0.5. So 0.95 is this point here, and we're trying to find what C is using the inverse normal in our CAD. So go to menu, probability, distribution, and go to inverse norm, which is number 3 there. And then just go enter. Now your area is going to be 0.95. Your mean is still going to be 10, and your standard deviation is going to be zero point 0.5, and just go OK, and the answer is going to be 10.82. So that's the answer for part C, which is 10.82. And then for part D, so I'll just share my screenshot again. So that's this one here. Okay, so we've got the answer for part C. So part D is going to be find K such that probability of X less than K is zero point 0.2. So same thing, probability of X is less than K is equals to 0 0.2. So, so in this case, your K value is going to be, so you have to use the inverse norm again on the CAS. So it's the same steps, but we're just changing the area under the graph to be zero point 0.2. So just go to zero point 0.2 and go enter. So the answer is going to be 9.579. So basically the same steps as before, but we're just changing the area. All right, so for part E, is to find C1 and C2. So probability of C1 less than X, and then less than C2 is equals to 0.95. So what we're looking for from a graph perspective, so these are normal, and then so C1 and C2, so this is symmetrical. So that means here, this area on the graph is going to be 0.95. So that means at this point, so I use a different color pen here. So I use red. So this one here, when it's less than, whoops, let me just clear that real quickly. Okay, so let's bring up my red pen again. Okay, so so this one here, when it's less than C1, so that's going to be, because this is symmetrical, so both the left and the right tail here is going to be half of 0.05, which is 0.025 here, and this is going to be 0.025 here. So to find C1, we've used the inverse norm again. So x is less than C1 is equals to 0.025 to find C1. And then to find C2 is basically x is less than C2. And that's going to be this area here of 0.95 plus this area here to find the inverse norm, and you get the C2. So the total area is going to be 0.975. So we use inverse norm for these two areas, and we're going to find C1 and C2 respectively. So let's jump back to our CAS. So we've got the inverse norm there already, so we don't have to go through the menu and go through the options. So you just simply copy that function and just change the first parameter to 0.025 like that, and that will give us C1. So C1 is going to be 9.02. And then for the second one, for C2, again, just copy the function above, paste it, and change the first parameter to 0.975 and go enter, and that's your answer for the C2. Okay, so that's it for today. If you've got any questions, feel free to comment down below. Otherwise, I'll see you in the next session. Okay, see you later.